The standard is ARCH.8.EE.C.7.A.8.3b. The learning target is I can give examples of linear equations in one variable with one solution, infinitely many solutions, or no solution. Sorry, there's a comma there. In the case of one solution, the example says solve for x. We're given the equation x plus 7 equals 11. So to isolate the variable, you want to do the opposite operation. So you want to subtract. Subtract 7 from both sides, because according to the addition and subtraction property, you can add or subtract a number or a variable as long as you do the same thing to both sides of the equation to keep it balanced. So we subtracted 7 to eliminate it, which leaves us with x equals, and then 11 minus 7 equals 4. X equals 4 is the one solution. Example, solve for x. 5x plus 3 equals 4x minus 1. So you want to subtract 4x from both sides. We're trying to combine like terms, so we want all the x's over here until we narrow it down to 1x. So if you subtract 4x from both sides, it looks like this. 5x minus 4x plus 3 equals 4x minus 4x minus 1. So as you can see, we're subtracting 4x from both sides. Now 5x take away 4x is the same as 5 minus 4, which is just 1. You're left with one of those x's. You subtract the coefficients, but you leave the variable as is. Bring down the plus 3, and then equals. This 4x take away 4x eliminates it, so you bring down the negative 1. Now you want to subtract 3 from both sides to eliminate it. So x plus 3 minus 3 here, and then a negative 1 minus 3 here on both sides. So this plus 3 minus 3 leaves you with x, and then a negative 1 minus 3 leaves you with negative 4, and that's your one solution. Remember, when you see equations that have variables with coefficients, that's a coefficient, that's a coefficient. You combine those like terms, they're like each other, and then solve for y. So you're adding the coefficients 2 and 6 and bringing down 1y. Minus 8 equals 12. Now you can see, to try to get this variable alone, you need to eliminate this 8. So you add 8 to both sides. So 8y minus 8 plus 8 equals 12 plus 8. So you have a balanced equation still. Now you can look at this side and see you've eliminated the 8, so you bring down the 8y equals 20. Now looking at 8y, you see there's a multiplication problem. So you have to do the opposite operation to unravel it. 8y, you must divide by 8 on both sides. So 8y divided by 8 equals 20 divided by 8. The 8 over 8 is equivalent to the number 1, so it's invisible, which leaves you with y equals 20 over 8. And that's the one solution. In the case of no solution, our example is 2x plus 7 equals 2x plus 8. If you try to eliminate 2x from both sides, as we have tried to do before, you end up with 2x minus 2x here and 2x minus 2x here, which just leaves you with 7 equals 8. No, that's not possible. So you have no solution. In the case of infinite solutions, you might see an example that looks like this. X plus 3 equals 2x plus 3. They are, if you add these x's together, in fact, the same equation. You might also see something like this. This also would give you infinite solutions because you can quickly see that x doubled is 2x and 4 doubled is 8. So effectively, they would both be the same line and therefore have infinite solutions. Finally, remember the distributive property. For example, if you have the number 2 outside the quantity x minus 3, all set equal to 15, you have to distribute the 2 to each term in the parentheses. So 2 times x equals 2x, 2 times negative 3 is negative 6 equals 15. Now, to solve for x, you must first eliminate all of the constants that are not attached to the variable. So we get rid of the 6 first, eliminate it by adding it to both sides. Now when we analyze this side of the equation, those two cancel each other out, and you're left with 2x, equals 21. Dividing by 2 on both sides allows you to eliminate the 2, so therefore you bring down the x, which is equal to 21 over 2. In the case of a negative number being multiplied by a quantity in parentheses, you're going to distribute the negative sign along with the constant. So a negative 2 times x is negative 2x, and a negative 2 times negative 3 is a positive 6, all equal to 15. So a negative 2x plus 6, you want to subtract 6 from both sides to eliminate it. Analyze the left side, which means that cancels out. You're left with negative 2x equals 9. 15 minus 6 equals 9. Now you're going to divide by negative 2 on both sides, which leaves you with x equals negative 9 over 2. And remember, 9 over negative 2, or negative 9 over 2, or the negative out in front, they are all equal. And that concludes this lesson.